an electron, and valence electrons, and free electrons. Now start with energy of an electron. An electron moving around the nucleus possesses two types of energies. Kinetic energy, due to its motion, and potential energy, due to the charge on the nucleus. The total energy of the electron is the sum of these two energies. The energy of an electron increases as its distance from the nucleus increases. Thus, an electron in the second orbit possesses more energy than the electron in the first orbit. Electron in the third orbit has higher energy than in the second orbit. It is clear that electrons in the last orbit possess very high energy as compared to the electrons in the inner orbits. These last orbit electrons play an important role in determining the physical, chemical and electrical properties of a material. Now, we will discuss about valence electrons. The electrons in the outermost orbit of an atom are known as valence electrons. The outermost orbit can have a maximum of 8 electrons, that is, the maximum number of valence electrons can be 8. The valence electrons determine the physical and chemical properties of a material. These electrons determine whether or not the material is chemically active, metal or non-metal, or a gas or solid. These electrons also determine the electrical properties of a material. On the basis of electrical conductivity, materials are generally classified into conductors, insulators and semiconductors. As a rough rule, one can determine the electrical behavior of a material from the number of valence electrons as under. Points 1. When the number of valence electrons of an atom is less than 4, that is half of the maximum 8 electrons, the material is usually a metal and a conductor. Examples are sodium, magnesium and aluminium, which have 1, 2 and 3 valence electrons respectively. Points 2. When the number of valence electrons of an atom is more than 4, the material is usually a non-metal and an insulator. Examples are nitrogen, sulfur and neon, which have 5, 6 and 8 valence electrons respectively. Points 3. When the number of valence electrons of an atom is 4, that is, exactly 1/2 of the maximum 8 electrons, the material has both metal and non-metal properties and is usually a semiconductor. Examples are carbon, silicon and germanium. Now, we will discuss about free electrons. The valence electrons of different materials possess different energies. The greater the energy of a valence electron, the lesser it is bound to the nucleus. In certain substances, particularly metals, valence electrons possess so much energy that they are very loosely attached to the nucleus. These loosely attached valence electrons move at random within the material and are called free electrons. The valence electrons which are very loosely attached to the nucleus are known as free electrons. The free electrons can be easily removed or detached by applying a small amount of external energy. As a matter of fact, these are the free electrons which determine the electrical conductivity of a material. On this basis, conductors, insulators and semiconductors can be defined as under. Points. Point 1. A conductor is a substance which has a large number of free electrons. When potential difference is applied across a conductor, the free electrons move towards the positive terminal of supply, constituting electric current. Points 2. An insulator is a substance which has practically no free electrons at ordinary temperature. Therefore, an insulator does not conduct current under the influence of potential difference. Points 3. A semiconductor is a substance which has very few free electrons at room temperature. Consequently, under the influence of potential difference, a semiconductor practically conducts no current. Thanks for watching this video. Please like, share and subscribe this channel. Thumbs up. फिर मिलेंगे next video में. नमस्कार दोस्तों.